Hello and welcome to your first helicopter briefing. Today you're going to embark on a truly memorable journey. The magic of flight is an exhilarating experience you'll remember forever. However, before you take to the skies and take control of the aircraft, it's a great idea to understand the basics. We're going to show you how to operate the controls and introduce some helicopter fundamentals. We'll be looking at the cyclic, the collective, the throttle and also the pedals. We'll also take a look at the instruments you're likely to see, as well as radio communications. We'll finish off by looking at what you should aim to achieve in your first helicopter flying lesson. Now we're going to be using a few cinema tricks to keep this interesting, as well as footage from real flights and cockpit situations. We'll also be using a virtual cockpit with a view you'll have from your seat. Like many good movies, you're probably going to have to watch this presentation a few times to get a complete understanding. But always remember, it's important to have fun whilst you're learning. Right, make yourself comfortable and let's get started. Now before we can really understand the operation of the controls, it's important to understand what a swash plate is and also the definition of angle of attack. You'll hear them both mentioned many times as you learn to fly, so let's get familiar with them right now. The swash plate is found on most helicopters under the main rotors. The swash plate's purpose is to simply translate the control movements from the pilot to the rotating main rotor. Half of the swash plate is fixed to the helicopter and half of it rotates with the rotor system. The rotating part is connected to the main rotor blades using pitch links. Now the swash plate can tilt in all directions as well as move up and down. Alright, on to angle of attack. Now as you can see from this diagram of a cross section of a blade, when the rotational airflow passes over a blade with little or no pitch, it will result in no lift. As the collective is raised, the pitch of the blade will be increased, creating lift, resulting in an increase in altitude. The cyclic stick control is commonly referred to as just the cyclic. Some helicopters have a cyclic located between the pilot's legs, however the Robinson 22 and 44 helicopters have a unique teetering bar cyclic control system. Now once you've got a hang of this system, you'll appreciate the ease with which you can get in and out of the helicopter. Now the cyclic is controlled by your right hand, and it's important to know that you should never remove your hand from this control during the flight. The cyclic tilts the swash plate assembly to one side or the other. Now this has the effect of changing the pitch of the rotor blades unevenly depending on where they are as they rotate around the main rotor head. The result of this is that the rotor blades have greater lift on one side and less lift on the opposite side. This will cause the rotor disc to tilt in a particular direction, producing thrust, which in turn takes the rest of the helicopter with it. Okay, now let's take a look at this in action. Now here we can see the pilot pushing the cyclic forward. The rotor disc tilts forward, which produces thrust in the forward direction. The pilot then moves the cyclic back, which tilts the rotor disc back. The next cyclic input is to the right, causing the rotor disc to tilt to the right. Finally, he moves the cyclic to the left, causing the rotor disc to tilt to the left. Okay, let's take a look at that one more time. Cyclic forward, cyclic back, cyclic to the right, and cyclic to the left. Okay, the collective. Now the collective pitch control, or just collective, is located on the left side of the pilot's seat. it raises the entire swash plate assembly as a unit. Now this changes the pitch angle of all the main rotor blades by the same amount to increase or reduce the amount of lift. So let's take a look at the helicopter on the ground. Now here the pilot raises the collective to increase the lift generated by the main rotors. Then he lowers it to reduce it. Now it's important to understand that there is a direct connection between the collective and the swash plate. You really are flying by feel. Okay, let's take a look at that again. Collective up, swash plate up, increase pitch, increase lift. Collective down, swash plate down, decreased pitch, decreased lift. Alright, now with the engine running, it's the same thing. Here the blades are spinning at the correct velocity, but the helicopter still does not move. This is because there is little or no pitch angle. The pilot now starts raising the collective and increasing the pitch angle. The helicopter becomes light on its skids and gently lifts off the ground. If the pilot were to continue raising the collective, the helicopter would keep rising. However, in this case, the pilot maintains the same pitch angle and the aircraft remains in a hover on a cushion of air. Now very gently he starts to lower the collective, causing the helicopter to descend and eventually touch down. Simple, really. Okay, the pedals. The tail rotor or anti-torque rotor of a helicopter is mounted on the tail of a traditional single rotor helicopter close to perpendicular to the main rotor. As its name indicates, its primary function is to counteract the torque that the main rotor naturally produces and prevent yaw. Now without the tail rotor, the body of the helicopter would simply begin to spin in the opposite direction to the main rotor, gaining momentum until all control is lost. Now the tail rotor is controlled by two pedals which are moved in and out by the pilot's feet. Pushing either of these pedals will alter the pitch of the blades, which will in turn adjust the amount of thrust being produced. Now remember, the helicopter is always trying to rotate in the opposite direction to the main rotor. Now when the tail rotor thrust exactly balances that torque reaction, the helicopter remains on a constant heading. Now for straight flight in an aircraft of this type, the pitch of the tail rotor is set to prevent the helicopter from turning to the right as the main rotor turns to the left. If the pilot were to push the left pedal, it would increase the pitch and the thrust of the tail rotor and turn to the left. If he pushed the right pedal, it would decrease the pitch and thrust of the tail rotor and turn the helicopter to the right. Now in forward flight, the pedals should be used simply to keep the helicopter in balance. And when the helicopter is in a hover, a little left pedal is required to counteract the torque of the main rotor. If the pilot wanted to turn to the left, he would increase the amount of left pedal, which would increase the thrust, resulting in a left turn. If he wanted to turn to the right, he would decrease the amount of left pedal, which would reduce the amount of thrust, resulting in a natural torque reaction, turning the helicopter to the right. Now, to recap, the main purpose for the anti-torque rotor is to provide the required thrust to overcome main rotor torque. The anti-torque rotor also enables the helicopter to have hover turn capability and balanced forward flight. While the tail rotor is normally linked to the main rotor via a system of drive shafts and gearboxes, so both are usually connected to the same transmission, meaning that if you turn the tail rotor by hand, the main rotor will also turn. Okay, onto the throttle. Now this is a motorcycle style twist grip mounted on the collective control. The throttle controls the power produced by the engine, which is connected to the rotor by a transmission. The purpose of the throttle is to control the engine power to keep the rotor RPM within allowable limits. Too slow and the rotor won't generate enough lift, too fast and you'll probably overstress something. Helicopter rotors are designed to operate at a specific speed. Sounds complicated? Not necessarily. As on the Robinson helicopters, you'll usually find a governor to maintain the correct RPM. However, on some other aircraft, the throttle is manipulated by the pilot to keep the RPM in the correct range. Now, one important thing to remember about the throttle is that it rotates backwards. Now, the experienced motorcyclist may have a little trouble with this, as it's opposite to the usual direction of a motorcycle throttle. Now remember, roll the throttle away from you as you look down on it to add power, and towards you to reduce power. Okay, the instruments. Now there are many instruments that have to be monitored in the helicopter. On first impression, they just seem to blur in front of you, and it can be a real headache trying to find the one you're looking for. And most training helicopters will have the same equipment, although it may be located in a different part of the console. Running along the top, we have a series of caution and warning lights. These light up if there are any problems with a part of the helicopter. Below this, on the left-hand side, we have the vertical speed indicator. This instrument tells you how fast you are climbing or descending, and if you are neither climbing or descending, then the needle will point to the left. To the right of the vertical speed indicator, we have the airspeed indicator. This measures the speed of the helicopter through the air. You'll notice there are some markings on it. Generally, try to stay in the green and certainly don't go past the red radial marker. The instrument on the far top right indicates both the engined RPM and the rotor RPM. This instrument has two needles, one for the engine marked E, the other for the main rotor marked R. In normal flight, the needles will indicate the same value and they are marked in a percent as opposed to a specific RPM. There are also colour markings on this style. Again, green is good, red is bad, and yellow is operated with caution. Now if we move lower, we can see how much power we are using by checking the manifold air pressure gauge. As we open the throttle or raise the collective, you would expect to see the manifold pressure increase. To the far left, we can check our altitude in feet. Now if we take a look at the panel below, we can see a carburetor heat temperature gauge and a clock on the left-hand side. On the right, we have a battery charge indicator, main and auxiliary fuel tank quantity, oil pressure and temperature gauges, and a cylinder head temperature gauge. Finally, below this we have nav lights, the strobe light, the clutch, the alternator switch, the master battery switch, and the ignition switch. Now this will probably be more than you can remember right now, but as you progress through your training, these instruments will become very familiar to you.
Charlie Guide, terminal information Golf, runway 12, left-hand circuit, frequency 118.1. Start approval required for seconds. Clearance required to cross runway 06 left. To Perth at Chile runway 03, caution wake turbulence above 1,000 feet. Wind bearing between 100 degrees and 170 degrees. Minimum 12 knots, maximum 24 knots, maximum crosswind 10 knots. Cab OK.
Now in addition to maintaining the stability of the aircraft by coordinating the cyclic, the collective, the throttle and the pedals, the pilot is also responsible for maintaining radio communication with both the ground and other aircraft. The correct frequency should be chosen, and to transmit, the pilot presses the radio switch located on the cyclic. When he finishes talking, he releases the radio switch which allows any response to be heard. When making a radio broadcast, it's important to say the right things, such as aircraft call sign, location, altitude, heading, and your intentions. During your first lesson, your instructor will probably relieve you of the burden of completing all the radio calls, but it's something you should consider as you progress through your training.
Victor Whiskey Oscar, I'll turn the session up and early. Assigned heading left 070, climb to 6,000, clear for takeoff.
Left 070, 6,000, clear for takeoff, 6
Lima Tango Lima, turn crosswind now.
Left crossing Lima Tango Lima.
Okay, objectives for the first flight. Now, as this is your first flight, you'll not be expected to take control of the helicopter like a pro. Gaining the skills to fly a helicopter with any level of skill can take many hours at the controls. At this time, it'll just be a case of getting a feel for the controls. When you are flying and your instructor gives you an altitude to maintain, try to keep the aircraft straight and level. Look at the horizon and try to keep it horizontal with the aircraft. Keep the helicopter in balance. Also try to gauge how fast the aircraft is going by looking at the attitude of the aircraft. If the aircraft is flying at 70 knots, look at the horizon and match that point with something on the windscreen, even a dead bug. If you increase the speed to 90 knots, you will have to push the cyclic forward, the nose of the helicopter will drop and the horizon will rise. Pick another spot on the windscreen to mark this. Now you should be able to roughly gauge your speed by looking at the horizon and the windscreen. Now if the instructor takes you down to do some hovering, see how well you can maintain stability. It's very easy to lose control. When you hear the words, "you have control," grasp the controls lightly, ideally resting your right hand on your leg. Most students find they over-control and the helicopter will feel uncomfortable. The trick is holding the controls lightly and using the smallest of control movements. When you get the hang of it, you'll find you'll be controlling with your fingers rather than your whole hand or even your arms. The professionals describe it as flying by thought. Now, in addition to this, make sure you have fun. Taking control of a helicopter the first time is the thrill of a lifetime, so remember to enjoy it. Before you go out to the aircraft, we'd just like to give you a briefing to ensure that you have a safe experience. Follow the direction of your instructor at all times. Never walk to the back of a helicopter with its engine running. Seatbelts are to be worn at all times. Hearing protection should be worn at all times, and you should also be in constant communication with your instructor. If you are approaching the aircraft when it's running, stay in view of the pilot, make sure you get the thumbs up before you walk forward, and stay low on entry and exit. In addition to this safety information, it's important to be able to hand over control of the aircraft between yourself and the instructor when the aircraft is in flight. When you are to be given control of the helicopter, your instructor will ask you to place your hands and feet on the controls. When you have done so, your instructor will say, "You have control." You must then repeat, "I have control." This must always be done to firmly establish who is flying the aircraft. Now when control needs to be returned, your instructor will come back on the controls and say, I have control. You will then say, you have control, as you remove your hands and feet. This procedure will always be done throughout your training. Well, that's all you need to know. It's time to go flying. Try to remember the things you've seen here, and remember, have fun.